Section 5.1, using fundamental identities. Find all 6 trigonometric functions given that secant of x equals -3/2 and tangent of x is greater than 0. To begin this problem, we need to remember what we have talked about in Chapter 4. Using our acronym All Students Take Calculus, it tells us which quadrant each trig function is positive in. So if we look at our first piece of information, secant x equals -3/2, you need to recognize that secant is the reciprocal of cosine. And we know that cosine is negative in quadrants 2 and 3. Tangent of x is greater than 0. All students take calculus means that tangent is positive in 1 and 3, which means our reference triangle then needs to be drawn in quadrant 3 because that's where secant is negative and tangent is positive. Secant being the reciprocal of cosine then is hypotenuse over adjacent. We can use Pythagorean theorem to find the third and missing side, which is going to turn out to be -√5. Once we have our reference triangle drawn, we should be able to identify each of the 6 trig functions fairly easily using our right triangle trigonometry. Sine, cosine, and tangent. Sine is opposite over hypotenuse, -√5 over 3. Cosine adjacent over hypotenuse, -2/3. Or reciprocal of secant. Either way, we could have gotten that solution. Tangent opposite over adjacent, √5 over 2. Reciprocal functions. Cosecant of x, secant of x, and cotangent of x. Cosecant x, reciprocal of sine, -3 over √5, and rationalize. Secant, reciprocal of cosine, or it was given to us, -3/2, and cotangent, reciprocal of tangent, 2 over √5, and rationalize. Example 2, and again, a lot of this section is going to get us set for what we are going to be doing in section 5.2, where we are going to be verifying trig functions or trig identities. And that's a big part of that is going to be taking all these individual tools that we're going to be learning over the next couple of days and applying them to that setting in section 5.2. So the first thing here, simplify. First thing we can do to begin simplifying is I can pull a sine out of everything. That leaves us with cosine squared minus 1. We have talked about when we see a trig function squared that we should always be thinking of our Pythagorean identities. If we look at our Pythagorean identities involving cosine squared, we know that sine squared plus cosine squared equals 1. If I solve this for sine squared, we get sine squared equals 1 minus cosine squared x. And we see that that's very close to what we have in this problem. We have cosine squared minus 1, which is the same as what we have on the right side here if we multiply by a factor of -1. So if I multiply both sides by -1, we end up with negative sine squared x equals cosine squared x minus 1, which now we can substitute that directly into our problem over here. Cosine squared minus 1 we now know is the same as negative sine squared. Multiply those together, and we get negative sine cubed of x. Okay, factoring here. Again, when you see the trig function, think of the trig function as being any other variable. So secant squared minus 1, our variable is secant theta. If that was x squared minus 1, we just have the difference of 2 squares. Same thing here, secant theta minus 1 times secant theta plus 1. Here we have a trinomial. Anytime we think about factoring trinomials, we know trinomials factor into 2 binomials. It's the same as having that trinomial there, which we should be able to factor, only the variable x is the same as tangent theta. So when we go to factor this into 2 binomials, we're going to get 4 tangent theta minus 3 times tangent theta plus 1. Remember, once that's factored into the two binomials, if we were going to turn around and FOIL that back out, we better get back to the original trinomial. First times first has to equal 4 tangent squared. Negative 3 times 1 has to equal negative 3, and your outside and inside products have to add up to 1. 4 tangent minus 3 tangent does equal tangent. Okay, the fourth one here, two different trig functions. So that would be like having two different variables, x squared minus y minus 3. There is no greatest common factor, so we can't do anything to begin factoring that until we make a substitution here. We want to write this all in terms of one function. Cosecant squared, again, we see a trig function squared. Think of Pythagorean identities right away. Cosecant squared is 1 plus cotangent squared. And now I have that whole expression written in terms of just cotangent. Simplify. We have cotangent squared minus cotangent minus 2. Again, a trinomial that we can separate into or factor into two binomials. Cotangent x minus 2 times cotangent x plus 1. Last one, simplify here. Again, nothing I can factor out right away. The key to this problem is to recognize and remember that every single trig function can be written in terms of only sine and cosine. So in other words, we can use reciprocal identities, quotient identities, but everything can be broke down into terms of sine and cosine. So if it's already in sine or cosine, I'm going to leave it alone. If it's not, I'm going to convert it to sine and cosine. So cotangent as our quotient identity is cosine of t over the sine of t. Cosine of t here I'm going to leave alone. Multiply those two fractions together. Sine of t plus cosine squared t all over sine t. Now we have two fractions we need to add together. In order to add fractions together, we have to have a common denominator. So this first fraction I need to multiply by sine squared t plus cosine squared t all over sine t. Again, we see trig functions squared. We see that. Pythagorean identities immediately. Sine squared plus cosine squared is equal to 1. So I'm left with 1 over sine t. And